In any case, so let's begin the lecture. Today we will finish up the concepts behind pointers. Um, and what I want to first mention is we can combine, right? After that, we can combine array and pointer. So my question is then, if we can combine array and pointers together, right? Can we do how do we represent a 2D array? So what would be the most obvious method to represent 2D array? Can someone tell me on the chat? 2D array. Yeah, basically the double bracket, right? Basically those are static 2D array, right? It's a static 2D array. So let's say I want to represent 10 by 20 metrics. That's the first option I can do. How about this? How about this second option? Does it work too? Yeah, essentially this is an array of pointer, right? So if I want to visualize this, right, what are you gonna have is first I have an array of 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there'll be 10 entries. Each one of them are pointers, right? And as I said, pointer can be allocated in an array form. So each one of these are another array, right? And one thing you can notice, right? I can now make each of these pointer point to an array of different sizes because now things get more dynamic, right? And you can go with the most flexible option, which is double star, right? What is this? What is this double star thingy? Yeah, it's a pointer to that points to another pointer. But if you think about it, right, the first level you can allocate and it can represent an array. The second level also represent an array. So if you think about it, it's kind of similar to this, but now you can extend and retract the first pointer, right? The size of the first pointer. So that's kind of like the differences. The other difference is one statically defined, right? So if you use a stack, the other one is dynamically defined. So that use a heap. The other difference is I can change the size of the arrays of pointer and pointer to pointer, right? In any way I want. So the last option is the most flexible, while the first option is the easiest to use, right? But it's not as flexible. So do you see the trade-off here? And now, if you have a static array like this, right? Essentially what happened, right? Um, when you handle this in C, right? And call function and say you want to return, how do you return a 2D static array? How do you return an array in a function? Because, I mean, a 2D array is going to be something like this, right? And let me ask you a question. Is memory, if you think about it, the memory, is it one-dimensional or two-dimensional? It's actually one-dimensional, right? So, and this structure is two-dimensional. So anyone wants to guess what actually happened? Yeah, basically you convert the 2Ds to 1D. You flatten this, right? You flatten this from two-dimensional to one-dimensional. So the second row will be next to the first row. The third row will be next to the second row, blah, 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 right? So hopefully that part is clear. The reason I said, please note that this doesn't play well with C's handling of metrics when passing around as function inputs and output is similar to an array, right? You cannot just simply return an array. What do you need? You need to manage the returning an array. Yeah, you need to basically rely on pointer, right? So now let's talk about the array of pointer, something like this, right? Something like this. Let me ask the first question. When I allocate in the end, if I want like a 10 by 20 matrix, right? When I look at this in the memory, are they going to be next to each other anymore? Do I have a guarantee, right? Or are they likely to be next to each other when I go through this array of pointer and do the malloc? So you have my memory, right? This is my memory. And here's my A, right? A is an array of pointer, size 10, right? The first one can be here. The second one can point to this location. The third one can point to this location, right? So now you see the difference here. Now that each second level of the array, right? Because you want to represent the 2D array. The second level can point to any location in the memory because you call malloc, and depends on what malloc return to you. It can be anywhere in DRAM. It doesn't have to be next to each other. All right. Any questions about this? But does it work as a 2D matrix? Does it work like a normal 2D matrix in here? Exactly, right? It works like a normal 2D matrix. It does that you doesn't guarantee that uh, each row would actually be next to each other inside the memory, right? What about this? This is kind of similar, right? To star A10, but what are the differences? Someone tell me what's the difference between star A and star A10 that I already mentioned earlier, I think 2 slides ago. So what are the differences? Which one is the most flexible? The one that I can shrink the size, or I can extend the size on both dimension X and Y. Which one is the more flexible one? The star A, right? The star A is the one that's more flexible. So now my question is, how do I pass them around? How do I pass a 1D array as an input? How do I pass a 2D array as an input? What's the easiest thing you can do to pass them around? We can use what? Yeah, use pointer, right? Because both of them are pointer. This is basically just, it can be something like int star A, right? This would be something like int star A, and you can dereference in order to get your data, right? So that's how we can actually now pass things around. And because pointers store the address, can I also return an array using pointer? Can I also return the whole array, but instead of returning an actual like, array, you return a pointer. You don't have to return anything, but you modify the content of things you want to return. That's possible, right? When you pass in pointers, one thing that's missing is the size of the array. So make sure you have that in all. Because let me ask you this: if you don't have the size, what would happen? So let's say I have this some function, right? Let's say it's called func, right? Int star A. And in here, I want to basically iterate over in the array A. How can I iterate over the elements in the array A if I don't know the size in the X dimension and the size in the Y dimension, right? So you want to pass in the size so you know where is the end of each the dimension, right? So you can pass a 1D array, right? Because as array are essentially pointers, it has a starting address. So you can pass them in. Something like this. I can do vector add by just do vector underscore in star A in star B, and you can actually just add them, right? But again, you might in the size of your array as well, because otherwise you don't know where's the end of the array A and where's the end of the array B. So that's one thing you have to be careful. We will do a demo for the vector addition, right? You can also pass to the arrays by passing the area pointer, something like this, right? Star star A star stars B, and size X size Y. All right. So, any question before we move on to basic data in C? And again, when I said basic data structure, the only thing we will talk about here is linked list. I will only talk about linked. Sorry, I need to erase this. I don't know what's going on with my mouse. And by clicking. So we'll talk about linked list. Do you want to do a 3 minutes break to do any Q&A to go over any content we have so far in the first 20 minutes, or should we move on? Q&A, quick break. Here's what I found. I'm not asking you Google. We aren't going to do sorting algorithm, right? I was planning to do that for assignment 3. Can I do that? All right. So now that we switch from the break and Q&A, so let's talk about the basic data structure in C. Anyone here have not taken the DSOOP class? I remember there's quite a handful of you, right, that haven't taken the data structure class at all. So this semester we will do something new. We won't talk about complex data structure. The only type of data structure that we talk about is the linked list. But remember, pointer is useful and you can use it to implement things like a tree, right? But in this class, we'll only talk about linked list. The reason why we talk about linked list is it is really good medium for you to learn how to use pointer. Essentially, it's applied to anything that requires next item. Require next item. If you're taking funpar, these are recursive data type. You basically can keep putting in next item forever, right? And here are the general guideline. First, you would declare a struct that consists of 2 things. First is the actual data node. Like this is what you store. Think of it as if it's an array of integer, the first thing that you have in the struct should be an integer. The second thing you need to add is because you have the next item, you need to be able to point to the next item. So the second thing should be a pointer. Optional, because you don't want to type many things, type def this struct. I'll show you the example. Then, because every single one of these data structure has a starting point somewhere, otherwise you can't refer to them, right? So you would first then declare a pointer to point to the first item. The first item, because it has a data struct, it will have the pointer to the next item, and then you malloc to append to the new node. So we'll do this in our exercise and assignments, right? But I'm gonna go through some basic concepts. So here's the linked list in C. Right? What is a linked list? Anyone taking DSOOP before? Anyone have taken DSOOP before? Can you raise your hand? Yes. Okay. So can you tell me what is a linked list? What is a list? Actually, for those who program in Python, what is a list? Yeah, it's a storage for elements. And again, my cat just randomly walked on the keyboard and jumped there. It's you can think of it as almost like a dynamic array. But if it's dynamic array, why can't I just use the dynamic array, like a pointer of it, like that points to a dynamic array? Yes. Awesome. Linked list is like by item extensible, right? I can add one more items anywhere, anytime without having to copy everything from one array to another. So it's more convenient. Don't write on that. That's all right. She was about to walk on the keyboard. Yeah. Today, I guess we'll have more cat attacks than usual. Sorry, I can't control them. Like, yeah, it's just impossible to control my cats. So the linked list is essentially a storage like that looks like an array, but when you want to add something into the linked list, you can add them one by one by one by one at a time, right? So here's how I would visualize this, right? This is the first item, and because they are linked, right? Because by the name it's linked, it's a list that one item linked to another. We will call this typically a node, right? As Garan suggested, right? With the first item, we call this a node. And you have the pointer that points to the second item, which is a node as well, right? Point to the third item, that can point to fourth item, point to the fifth item. So if I want to add one more elements at the end, what can I do? So let's say this number is store number 2, number 3, number 1, number 5, number 7, right? If I want to add one more elements, yeah, just have this node 7 point to the new node I just created, right? Let's say 8, right? So anyone have any question about this? So the next question is, how can I tell that that's the end of my linked list? How can I tell that that's the end of my linked list? Oh, it can also go the other way. So if you want to go, thank you. So basically, at the end, you can point to now, right? Anyone that like take I think high school physics, basic circuits. What does the symbol mean? This one. Yeah, I love this. Like usually when you have a pointer pointing to now, I'll just draw a ground, right? Because if it goes somewhere that I mean it doesn't really go anywhere to the next item, right? And how can I tell that's the beginning of my linked list? I would then have another pointer, right? That point to the first one. All right. So let's zoom in. Let's zoom in and think about what goes in there. Now, what is the type of this linked list? So for those who are taking fun part, what is the type of this linked list? What does it store? It's a node, but what's in the node? What is on it? It's just an integer, right? So to create the node, right? To create the node, let's say this is my node. What should be the data type that obviously should be in there? Integer, right? So I can just say something like int data, right? Exactly, right? My node has to have the ability to point to the next item, right? Because otherwise it's useless. I can't point to the next item. So what do I need? I then need a pointer, right? So if I want to have a linked list that contain integer, I also need to have the pointer. What is the so let's say this is the struct node, right? Let's call the type struct node. What should be the type of my pointer? What does the pointer point to? What does the pointer point to? The next node, right? So let's say we type def already and we now have a data type called node. Now my pointer to declare this, right? You can do something like node pointer, right? And then let's say the name is next. This allow you to then point to another node, right? Point to another node. And here will be the int. Here's the pointer type. Again, point to another node, right? Int pointer, which then point to another node. Any questions? Now we will have a demo on how to do this. And the demo would basically going through the insertion. I think we'll do this on Thursday so that we have more time to do the Q&A for assignment 2 at the end of this class. But let's visualize how do I insert something to my linked list, right? So let's say here is my linked list. I have the first item pointing to the second item, pointing to the third items, pointing to the fourth item because I have no room. Let me draw it this way and then now, right? And let's say I have number 1, 4, 5, 7, and I want to insert a node, right? With number 3 in here, right here. What should I do? What are the tasks that I have to do in order to make sure that you have a linked list with 1, 3, 4, 5, 7? First thing I can do is I point node 3 to 4, right? And then this pointer, I get rid of this link. Now it should point to the node 3, right? That's it. Any questions? Any questions about this example? Now, let's say I have this linked list, right? The one that we just insert number 3, 1, 3, 4, right? 5, 7, right? And then this point to nothing. How do I go through this list? One thing I can do is I can loop. Let's say I have also a pointer called first, right? That point to this. I can do something like this. For node star temp equal first. How can I check I'm not at the end of my linked list? What should I check? Temp is not now, right? And then how do I move to the next one? What do I do at the end of the iteration? Temp equals temp next, right? And then I can do whatever, do something inside the loop, right? Any questions so far? Any questions so far? Now I can go through my list. It's just so that I can go through them. Temp is a pointer, right? It's a pointer that I create temporarily inside this loop. So I can go from the first item to the second item to the third item. All will be called temp. It's just a pointer. So that's what temp is for. Oh, is it more clear? Any question? Please say it right now that it's still confusing. I define a variable, right, called temp so that I can use this name temp to go through node 1, 3, 4, 5, 7. So the first iteration, temp would be this one. And when you go to the next iteration, temp will move here. The next iteration, temp move here, right? The next iteration, temp move here. And then the next iteration, temp move here. That's how I can go through all the elements. So let me ask you this question, right? If I want to go through my list and then change, say, the number 4 here to number 8, right? I want to change the number 4 to number 8. Which one is faster? Should I do this? Is the linked list faster or is the array faster? Which one is faster? Linked list or an array? An array is faster. Why? Why? Why is that faster? Yeah, because if you have the index, you can just go to that element and change it, right? If you have the index for the array, you can change it right away. For the list, even when you have the index, say you know it's the third element that I want to change, you go to the first, second, third, and you want to change that guy, right? You still have to go to the first, second before you arrive at the third element. So array typically is faster. All right. How about when I want to modify the size of my data? Which one is faster? I want to add something to my linked list versus an array. Which one is faster? So linked list seems faster. How about an array? What's the overhead of an array? Garan, you got it right, actually. Depending on how we add this, because you cannot guarantee whether you have to walk through your linked list or not, right? And for the array, typically they can be slightly slower because sometimes you need to create a bigger ones, right? So adding depends, right? But if you want to add to the end or adding to the front, the linked list typically is a faster one. Uh, extending the size of your data structure, linked list definitely is a lot faster. Array, you have to create a new array, you have to copy all the items, right? How about deletion? So let's say I have this array, not array, sorry. If I have this linked list that look like this, right? 1.23, 0.24, 0.25, which 0.27, right? And say I want to delete the node 3. How do I do this? How do I delete this? Yes. You make sure you save this location somehow and make sure this point to this location. And then you free this node. And that's all, right? That's all. Okay, so we will do a demo for the linked list on Thursday. We will do both of this today. And before I switch to the demo, I will first talk about in class 7, right? I want you to do a matrix transpose based on the demo we do today. Uh, we'll do a 10 minutes break. We'll resume at 3 o'clock, all right? So at 3 o'clock, I'll set up my desktop to make sure I can do a demo. So I'll do it right now, actually. And then we'll come back, right? We'll come back and do the demo to deal with the vector addition and matrix addition. And then we'll switch to in class 7 and we'll go to Discord. And you have any questions about assignment 2, let me know at the time, all right? So let's do a quick break for 10 minutes. We'll be back at 3 o'clock. Here, all right? So as we discussed, right? Let me adjust this a little bit. As we discussed, we will do a sample. The first one is called vector add. Yes. Do you mind if I copy the code from the previous lecture here, so I don't have to reinitialize the array and do the printing? I'm lazy. I'm sorry. I'll copy that code. And now I have the array. And I have the second array. Let me know if there's any bugs you spot, like I forgot a semicolon or something, right? That would speed things up quite a lot. And that would also test whether you're with me or not. All right, so can someone tell me what have I just done? What have I just done? What am I doing now? Print the array A and B, right? Can someone give me the size of the no, not the number for array B? Any random number between 0 to 1000. Right. 0, 420, 1000, 9, 888, 666. Is that the 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we are perfect. All right. How do we add them together? How do we add them? But I want to use the function call. Do I have to return anything for vector add? Can someone tell me, do I have to return any number? Yeah, basically we add the integer at the same index, right? And what's my input? And now what did I forget? What should I have at the end? Size, right? And let me ask you this question. If I don't have the size, how do I loop around and add them together? Okay, let's go with that option and see. Uh, let's go with this first, right? And we'll see if that works or not, right? We will see if that works or not. And the way to safely test this, right? The way to safely test this. So let me just do this. Right? Print out my size equals SMD, right? Okay, how about we test this first? If I can use size off to check the size of my array. Line 25, something is wrong. So let me go there. Printf does nothing. My size is 8. Does it work? No, right? It basically checks the size of my pointer. It checks the size of my pointer. Why? Anyone want to take a guess? Why is a pointer 8 bytes? So this is 8 bytes, but why is that 8 bytes? What does the pointer store? It stores the address, right? So say you buy a DRAM in a 64-bit machine, what is the possible value for your address? The maximum number of your highest address you can have. In theory, not in practice. In a 64-bit machine, like your any modern processor nowadays, your pointer can point up to the 64. That's, I guess, -1, right? That's why it's 8 bytes. That's why it's 8 bytes, because your address can be in any of those locations. In reality, I think right now with the current Intel chip, like you're at, I think, 52 or 53 or 55 or something around that. That's the range of the what Intel specification put in. Say, hey, we can use these many, and then there's some extra bit for other purposes. Um, that also depend on the hardware manufacturer, but 50 something bits is definitely more than enough for your data, right? That's like even more than petabytes of data. So there's no way you go that far for now, right? For now, I'm not sure about in the next 100 year, right? But for now, it's definitely sufficient. So that's why my size is 8. And as you can see, right, it doesn't really give us what we want, because when I say my size input 1, it doesn't check how many entries are in the input ones. It just check what's the size of my pointer, right? So this thing doesn't work. I actually need to put in the size, right? Now, what do I do? How do I add the input 1 and input 2? What can I do here? Can I do this? Will this work? So let's say this is option 1, right? Let's go with also option 2. How many people think option 1 works? All right, just one response. Thank you so much, by the way. How about option 2? Yes, you got it correctly. I think both work. Right? Both options should work. So let's test it one by one. So let's test option 1 first, right? Assuming I write code with no bug, that's a big assumption, but it does work. Um, so that's the addition of the 2 array, right? Now let's try option 2. See, the same thing, right? So both option works. The reason behind that is when you write this bracket in the array like format in C, something like option 1 here, what happened is the compiler would convert the index I, right, to the correct address anyway. Now let's try something funny. Let's try something funny. Way too many parentheses. I can just do this. What have I just done? What have I just done? I typecast, right? My input, output, and input 2 from integer pointer to character pointer. So let's see what will happen. So first question, will that compile? Can I compile this? It will, right? Because we can do whatever we want as long as it's syntactically correct. What I just did, I just changed int pointer to char pointer. Now your output is going to be really weird. Anyone want to guess why? Yeah. So now what actually happened, right? If you look at the code, if I have output as a sharp pointer, will that go 1 byte at a time or 4 bytes at a time? It's 1 byte at a time, right? So when you do the bracket I, everything gets really weird. So do you mind if I just correct it and go back to option one? I just want to do a quick demo to see that, hey, this is possible to compile, right? And you can run it. The answer is not correct for sure, right? Basically, it also means that be careful. Yeah, but why? Sometimes you need to cast a type. Sometimes you need to cast a type. Why? Remember this example that used Q-sort. Remember our quicksort example here? We actually need to cast from const void star to int star, right? So that's why. Sometimes we need to cast it, but we want to make sure we cast it to the right format. All right. So are you all with me? Any questions? Any questions about this? This is actually why C is powerful. You can do whatever you want with it. And also why C is buggy in many cases, because you unintentionally write code that supposed to do one thing and say you cast it wrong and yay, fun, right? But this applies to many other languages as well. It applies to many other languages too. Yeah, it allow you to run things, and it would try to treat your command with the absolute like godlike way. Do that. In many other languages, sometimes there's like some safety check. I say, hey, do you really want to do that? Right. In C, you can also turn on warning as well. We'll go through that. When we talk about makefile, different flags in GCC that you can put in, right? All right. So because I'm lazy, I will copy my own code and change this to metrics, right? And then I have double pointer input 1 and 2, and then all right, give me a okay, I need to change this. I need to do it 5 by 5, otherwise it's gonna be too big. So there was a question whether I can predefine the value of my 2D matrix, and here's how. Because I'm lazy. Sorry, folks. Okay. And sorry, I'm lazy. I'll just flip some order here and go with it. All right. Sorry for this awkward silence, but this is literally I need to print things out. This take a while. All right, almost done. So how should I do this? In B. Yes, yes. Thank you so much. Anything else that I might have doing it wrong? A, B here, print C at the end. I put A, B, C as an input. So, right, one thing I can do is size X over here and size Y over here. And then I'll put J here. Now, let me ask you this question. Can I do this? All right, first question, can I do this? So let's try. Oh, metric that. All right, tons of warning. Processing a given tree of metric counts. Let me check first. Input 1, input 2, output. C is so that warning is fine. Basically, it was expecting the pointer of array. I mean array pointer, but we pass in just 2D array. All right. Let's run it. Seg fault. What does segmentation fault mean? Can someone tell me what does segmentation fault mean? It's actually try to access the location that you did not own, some index out of range, right? It touched the memory at the location that you should not have done. So one thing, let me show you one quick thing that you can test what line caused the seg fault, right? You can first add -g. That allow you to use GDB, right? And then if I want to show what line, right? What line caused the seg fault, type run. Type run, and it would tell you that line give you the seg fault. Output ij equals input 1 ij, input 2 ij. Oh, sorry about that. Yeah, task 4 can have a bunch of seg fault. One handy command that you can do is called backtrace. Also would see what function has been called and where are we right now. So in this case, let's go to line number 8, right? It actually highlight matrix add.c, line number 8. That's where I stopped because I got seg fault. Oh. So that's how you can tell what line caused seg fault, right? Now, if you go back to this line, let me ask you one quick question. If I say output ij, how can I tell the location, the address, right, of the output ij? So let's first go with option 2, right? So let's comment out option 1 as we know it, but now we go with option 2. How do I use pointer? How do I use pointer with ij? I can do this. Output plus I, right? And then I first dereference, right? I first dereference and then plus j again, then I will dereference this. Sorry about the so many parentheses. I cannot help it. You kind of have to put it that way because you need to end the parentheses before you do the dereferencing. Will this work? Someone tell me if this is going to work or not. Let's try. Still seg fault, right? Still seg fault. So let's debug this one at a time. And out, right? We'll set the breakpoint at line number 8. So that's the run, right here. We are at that line. Print INJ. Okay. Right. Now I'll go step, right? The next iteration. Print I, print, oops, sorry. Print J, right? Oh, it's already seg fault, actually. Sorry. Now, it's already seg fault, and one thing we'll do is let's check these addresses. Let's check these addresses and see if we can access those addresses, right? Let's see if we can access those addresses. So let's quit for now, and this is my plan. This is the plan that we should go through. First of all, we pass in input 1 and input 2, and we pass out the output, right? Over here, the input 1 is A, B, and C. That's line number 34. So what I'm going to do is I will stop at line 34. I will print out the address of A, the address of B, and the address of C. All right. And we will check if that's the same as the address of input 1, 2, and output, and see if we can dereference this. All right. So go back to GDB and we'll do a breakpoint at line. Oh, I forgot. 34, I guess. Yes. Print A, print B. Oh, sorry. Print, I guess, the address of A, address of B, and address of C, right? Now, use that. What is input 1? Can someone tell me what's going on here? Is a different address? Yes. So why? Why is that? So we should we pass in the address? How about this? Instead of a static, so let me go with this. Let's do one thing first, right? Instead of allocating your metrics this way, how about we use malloc? Let's first do this. How about we pass in the address of A, B, and C, right? So that's your suggestion. So let's go with that first, right? So now is it double pointer or triple pointer here? All right, let's see if this works. Oh, sorry. It's still seg fault, right? What if I do this? What if I get the address of A, B, and C, and I use the double pointer? Will that seg fault? It will still seg fault, right? So any suggestions? Any suggestions here? We try to pass in the address of A, B, and C, right? The receiver end still seg fault, even when we do this. We will actually let me first, instead of doing this double pointer, let's first clear, let me comment this out, right? Just for the sake of simplicity, because we will resume back to this example. But let me create my array using double pointer for the sake of simplicity, right? And now, how do I do this? How do I malloc? So that I can also show an example of how we can malloc. Right? Then let me know if I forgot something, because I intentionally left out something. So if you spot that, feel free to type in. This will still do seg fault as well. Yes, thank you. So now the first thing you have to do is A, right, equal malloc, right? That's the first dimension. If we don't do this first, this part will seg fault, because I do A plus I, and I did reference that, but A doesn't have the LAN of its own. So it will give you the seg fault, right? And because we want to add 5 items, right? So we will do 5 items for each dimension, right? And let's just, for the sake of my own sanity, right? I'll just initialize the value. Oops. I don't know. Okay, I guess. How about this? We initialize the array, right? Ah, thank you. Another bug. It should be in pointer. Anything else that you spot that is wrong? All right. So let's just go with this. I have malloc everything, right? And I pass in A, B, and C. What is the value of A, B, and C in this case? What's the value of A, B, and C? It's now double pointer, right? It's actually now double pointer. And over here, because it's the double pointer, I don't have to do this. First dereferencing, right? Let's try to compile. First of all, right, see the warning disappear. the warning disappear, except for I forgot to include standard library.h, right? But one thing you would have noticed, the warning about different mismatched data type, they all disappear. That actually has something to do with the 2D array, like 2D array versus array of like 2D arrays of pointer to pointers. But let's run this. There's no seg fault. There's no seg fault. And you correctly add the two metrics. All right. So I will stick with this for now. We will discuss what happened to the first metrics later. I thought we have more time, but we'll continue with what's up with this? Why is it wrong? You are very lost, right? But the first thing you should understand is if you malloc, you got an address. So A is an address, right? Now A is an address to the first level, first array. Each item in the array is also an address containing the second array. So you with me so far, right? At least for now. Forget about A55. But for now, if we use malloc, A, B, and C, all of these are valid addresses. All right. All of those are valid addresses. So when you pass in A, B, and C as an input to matrix add, right? These address input one is going to be the same as the address A here, right? The address of A here. Input two is going to also be the same as B right here, right? The same thing goes with C, right? And the output is the same address. So you can do pointer arithmetic where you would do output plus I, the reference plus J, and then the reference to get the correct location and assign a value, and everything looks correct. We will then, in the next lecture, discuss what's happening here. Why is this not working? All right? Why is this not working? We'll switch to in-class exercise because I want to make sure that first, let me save this and then I copy, right, the whole sample code to this location, E3, and here. So you can go check out /sample code /2021 T3 sorry, it's lowercase t. And you see each lecture's sample code, right? So there's also lecture 9, more pointers here, right? That also should be lecture 8, function pointer. Here, so if you go up one level, you should see lecture 6, 7, 8, and 9 sample code. The sample code for metrics add, you can use that as a starting point for your transpose, which is your in-class exercise 7. Again, the last 10 minutes, please, let's go to in-class exercise 7. When there is the exam, we will talk about that on Thursday. So Thursday we'll be discussing admin stuff like when should the exam be. We will talk about more example. We also talk about what is going on with this part of the code where we have the array defined, but we can't add them. We cannot add them somehow, right? How do we fix it? How do we fix it? And what actually is going on? So that's for Thursday. Also, we'll cover like Makefile on Thursday if we have time, because that's needed. Like at least you need to know the concept of the Makefile for assignment 3. And then we'll also pick the day for your exam because I want to make sure that no one here has to suffer the case where you have 3 exams on the same day. All right. So hopefully that answered all the questions. I know there's only 10 or 15 minutes left, but please use the rest of your time to do the transpose. And it's actually pretty easy if you have this code as a starter code. So go to go to this directory on our server /sample code /2021 T3 lecture 9 more pointers. And you can actually start from metrics add to get your transpose.c going. The function signature is, well, so now you're super confused with star and ampersand. We will go there on Thursday as well. So hopefully Thursday will be that day where hopefully everything gets asked and everything is more clear. All right. And now we're done with pointers. So I think Thursday is a perfect day for that too. It's only 2 days from now. Hopefully you don't clear everything you learn. Hopefully you come with questions. Please come in with questions. Thursday will be a Q&A, not for your exam, but a Q&A for your lab, for your questions from the lecture, questions about 3-star, 2-star, like double pointer, triple pointer, what's going on, right? Anything will be asked on can be asked on Thursday. We'll go through that. Hopefully the Q&A lasts for the entire 2 hours and it's exciting. If not, I'll keep blabbering things about Makefile. If we don't have time on Thursday, we'll talk about Makefile on next Tuesday. All right. So now do the practice on the in-class starter course form. Yeah, just copy the metrics add and change the function name, change the function inputs a little bit so that you have size X and size Y, and make sure you do the transpose correctly. And you can just test it using the same metrics, or if you want to use different metrics, it's fine too, so that the X and Y is not the same size. That's also another legit thing you can try. All right.